Welcome to BC Mnemonics. In this video, we're going to be taking a look at this combination inclining and analemmatic sundial. Now, what makes this dial particularly interesting is its ability to self-orient, that is, face true north without the use of a magnetic compass. It accomplishes this by including both an hour angle and azimuth dial. Now, before we dive into the actual mechanics of the dial itself, let's dive into the underlying mechanics of these two types of sundials. Starting with the hour angle dial here, we see that it has a polar gnomon. Now, this means that the gnomon is parallel to the axis of the celestial sphere, and for this reason, it does not need to be adjusted for solar declination. As you can see by the diagram, regardless of the date, the sun's path will always be perpendicular to the axis of the celestial sphere, and therefore the gnomon. Because of this, the angle cast by the shadow of the gnomon at any given point in the year will be the same. So at 4 p.m., the shadow will always indicate this position, seeing as the sun, in its arc around the axis, makes the same angle with the gnomon. The length of the shadow may change, being shorter in the summer and longer in the winter, but that does not impact the position and angle of the shadow relative to the base of the gnomon. Now, looking to the analemmatic dial, we see that it does not have a polar gnomon, and instead a perpendicular gnomon to its dial face. Now, this is because the azimuth dial reckons time not based on the sun's arc around the celestial axis, but instead based on its position relative to the local horizon. Now, because the sun's position along the local horizon changes over the course of the year, the analemmatic dial must also change to account for that changing solar declination. In the winter solstice, its gnomon is farthest south on its dial plane to match the winter solstice farthest south solar arc. Likewise, during the summer solstice, the gnomon is pushed farthest north on the scale to account for the changing solar declination, being farther north along the local horizon. Now, because the hour angle dial and the azimuth dial operate under different mathematical bases, when their hours align with each other, that is, the gnomons are casting the shadows on the same hour on both dials, then you can know that the dial itself is pointing true north and that the hour is the correct current solar hour. Now, with that out of the way, let's figure out how to use this dial itself. So the first step is to incline the dial to the latitude of use using this included latitude scale. Both of these dials are laid out for 35 degrees north, but with the aid of this scale, they can be made to be used at different latitudes up to 60 degrees north. So I will fix the dial plate at right about 44 degrees, as that is my latitude. With this done, the only remaining step before we actually put the dial in the sun is to set the analemmatic dial for solar declination. Now, it's just past August 20th, so I'm going to slide the analemmatic dial's gnomon right up to that second mark of August. This particular dial is set up for the Gregorian calendar, but it also features zodiac scales. Now, orienting to the 20th of August. The only remaining step is to set this dial out in the sun and rotate it. So this is where the underlying mathematical principles of the two dials come into play, as for any given orientation, except for the correct one, the shadows of the dials will not agree. They'll show different hours. But once the dial is rotated into the plane of the local meridian, that being the true north-south line, the shadows will agree, and you can know at that point that you're seeing the correct solar time. Now, I'll just simulate this with a flashlight here, just for demonstration purposes. So as you can see here, as I have the shadow, I'll just turn it to a random position, let's say there. As you can see here, the shadow of the hour angle dial, the inclining horizontal dial, is pointing to 8 a.m. However, this is not the same hour that the shadow of the analemmatic dial points to. If you were to extend this shadow through the ellipse, it would intersect with the hour point right before 6 a.m. So as you can see, 8 a.m., 6 a.m., they do not match. But if I rotate it, you'll see that these shadows will begin to converge on the same time. And here, we have an agreement. So both shadows are indicating 9 a.m. Now this would tell us, if this was actually the sun, that this plane right here, this vertical plane, is the correct local meridian, and that 9 a.m. is the current solar time. Now that will conclude this demonstration, and I thank you for watching.